Hello, in this video I'm going to introduce biconditionals. What's a biconditional? Well, we'll get there, but first let's review that in many cases if you have a conditional that goes in one direction, the conditional that goes in the other direction is not true. So one conditional is true, the other's not. So we have if Sandra lives in Torrance, then Sandra lives on the west coast. This is true. We can symbolize it as if T then W. This conditional, if Sandra lives on the west coast, then Sandra lives in Torrance, is not true. We can symbolize it as if W then T. Right? If she lives in Torrance, then yeah, she lives on the west coast, but there are lots of places you could live on the west coast besides in Torrance, and so that looks false. So, in this case, we have one of the conditionals is true, the first one of the conditionals is false, the second one, and we can note that if T then W does not imply if W then T. So in this case, the conditional goes one way from T to W, but not the other way, not from W to T. Okay, so one conditional is true, the other is false. And that can happen a lot. In other cases, however, the conditionals going in both directions may be both true. So suppose we say if Sandra lives in California, she lives in the largest state on the west coast. Well, that's true. Let's symbolize that as if X then W. So Sandra lives in California will be symbolized by X. Now consider the conditional going in the other direction, what we call the converse, but in any case, the conditional going in the other direction. If Sandra lives in the largest state on the west coast, she lives in California. Well, that's true too, and we would symbolize that as if W then X. So we have the conditionals going in both directions. We want to say they're both true. So sometimes both conditionals are true. Sometimes the conditionals agree by being true, both of them. Now, when both the conditionals are true, or actually when both the conditionals are false, whenever the conditionals agree, it turns out there's a concise way of saying it, a shorter way of saying it than saying both of them. And that's what the biconditional does. But to see that it's doing that, it helps if we restate the original conditionals a little bit. So we'll start with if Sandra lives in California, she lives in the largest state on the west coast. Well, we know that the left to right order doesn't matter in terms of what this sentence means. What matters is what the if hooks onto. So we could reverse the right to left order, and it means the same thing. We can say Sandra lives in the largest state on the west coast if Sandra lives in California. Those say the same thing. Now the second conditional was if Sandra lives in the largest state on the west coast, she lives in California. Okay, we can change this from an if sentence to an only if. How do we do that? We take the if off the beginning and we put the only if in the middle, because remember, only if flags the consequent. So we move the if from the front to only if in the middle, and now we've restated the second conditional. So we have these two statements, and if we look at these two restatements, the difference, the left to right order is the same. What goes in the middle is different. In one we have an if, and in the other we have an only if. So to say both of these conditionals at once, we just stick the if and the only if together. We say Sandra lives in the largest state on the west coast if and only if she lives in California, and now we've said both of those conditionals together in a more concise formulation. We didn't have to say both of them and repeat ourselves. So that's the biconditional. So we have this sentence, we can say square if circle and circle if square, or you can say square if circle and square only if circle, or we could say square if and only if circle. And all of these say the same thing. And yeah, they all mean the same thing, and the most concise way to say it is the last, square if and only if circle. Why? Well, because we don't have to repeat square, and we don't have to repeat circle. Of course, here square and circle are short, but when they're actual sentences, they're much longer, and so even here, the last one we can see is the most concise. So we use this symbol to symbolize this. The sentence is like that. So we write box, then this symbol, and then the circle, and we call it a biconditional. We call the symbol IFF with two F's. We call it the biconditional. We call it the double arrow or the left to right arrow. And it just symbolizes if and only if. So we have Sandra lives in the largest state on the west coast if and only if she lives in California. Okay, well that's W if and only if X. So we put that double arrow in between the two components instead of putting a one-way arrow. And that's basically what there is to symbolizing biconditionals. One important thing to understand about biconditionals is what they say. So we have our biconditional, Sandra lives in the largest state on the west coast if and only if she lives in California. And we symbolize that as W if and only if X, or W double arrow X, W left and right arrow X. This doesn't say that W and X are true. The conjunction says that W and X are true. This says that W and X agree. So it says either both are true, Sandra lives in the largest state on the West Coast, and she lives in California, or both are false. She doesn't live in the largest state on the West Coast, and she doesn't live in California. So this is not a conjunction. It doesn't say that W and X are true. It says that W and X have the same truth value, that they're both true or they're both false, that they agree. That's what the biconditional says. So in next video, I will talk about derivation rules and strategies for working with biconditionals, and then we'll have an examples video showing some derivations with biconditionals.